Unit 6. This is Lesson 3. Is it smart to foul at the end of the game? Today we're going to be defining a binomial random variable. And this is the first day we're going to be talking about binomial random variables. Okay, the first thing I did before actually starting the lesson is I had everybody do a warm-up. And I was trying to remind them how to do what is called 10 choose 4. And reminding them that 10 choose 4 can be written as 10 choose 4, or it could be written as also this. Oops, I switched it, sorry. So this is all the same thing. Well, the reason I have it written as here is because this is how you get it in your calculator, and as it shows up here where it says hint, from a calculator page, you go menu probability combination. So I'm going to show you on the calculator page. So open up a calculator page, and I go to menu, probability, combination, and you notice NCR comes up. So I'm going to hit 10, 4, and you get 210. What 210 represents is that I have 210 ways that I could have, let's say, 10 people to choose from, but I've got 4 spots that I can choose, and that's it. So I have, 1, 2, 3, 4 spots, right? And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people that are wanting one of those 4 spots. And there are 210 ways that I can choose these 10 people. Now, if I ask, I have 5 students are available for 2 spots, how many ways can this occur? And so this is going to be 5 choose 2, or again, NCR, 5, 2. Now, of course, that's on the calculator, and I just want to remind you what this is. Remember, that's the top one is 5 factorial over 2 factorial, and then 5 minus 2 factorial. And if I got to remind you what 5 factorial means, it means 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 5 minus 2 is 3 factorial, and that's going to be 3 times 2 times 1. Of course, if I simplified this, this would cancel, this would cancel. I would get 5 times 4 is 20, divided by 2 is 10. And if you put this in the calculator, you're going to indeed get 10. So you are allowed to use your calculator 100% of the time. I just want to remind you what is going on behind the math. All right, so I started them out with that because we're going to be using this on our notes today. But what I wanted to do is I wanted to show you kind of how we're going to be doing the binomial random variable today. So to do the binomial random variable, we are going to use a basketball game. In 2005, there was a basketball game, and Memphis trailed Louisville by 2 points. At the buzzer, Darius Washington attempted a three-pointer. He missed but was fouled and went to the line for the 3 free throws. So this is kind of the setup, and you can see, I'll kind of narrate it as it goes on. And this is Darius Washington dribbling right now, and he is about to attempt a 3-point shot because they're down by 2 points, and you can see that the game's over. It appears that Louisville lost. However, it appears that Memphis lost. However, Louisville fouled him, and since they fouled him while he was attempting a 3-point shot, what happens is that he gets 3 free throws. And it shows you right here that he gets fouled, right there, and he's going to get free throw attempts. Okay, so we're going to look at the first shot and see what happens in just a second. So the first thing what I have you doing is let's write all the possible ways that he could actually make or miss a shot. So I have the first thing is the way he would win is he'd have to make all 3. Then, of course, he could make 2 and miss 1, but he could make the first 2, or he could make the first and last, or he could make the last 2. So this is make 2, miss 1, and of course this would be 2 points, and that would throw him into overtime for 2 points. Or he could lose the game, and to lose the game, he would he'd only make 1 and miss 2, or he could miss the first one and make the other 2, or he could miss, and then make. And this would be a lose. Or he could also lose by just missing all 3, and that would also be a lose. Okay? So I have 1, 2, 3, 4, 5, 6, 7, 8 ways, and let's see if we put it in the calculator, see, because I have 8 different ways that these events could happen. So the first thing I want to show you is it says Darius Washington was a 72% free throw shooter, so that's his probability. Find the probability that he will win, lose, or go to overtime. If you see this formula here at the top of the page, it is on your formula chart, and it's going to be the formula we're going to be using today. The yellow part is the choose part that I just talked about. So for instance, for my overtime, this would be 3 choose 2 because I have 3 shots and I'm making 2, and that would actually get me, if I put in my calculator, it's going to get me 3. So the yellow part is the number of ways what I'm doing can occur. P is the probability of success. So this probability of success of is going to be 72% always, and the probability of failure is always going to be 28% because the probability of him missing is 28%. So the base of all of our equations today is going to be, the probability is going to be, the yellow part is going to be, I have 3 shots, and then this is going to change. The probability is going to be 72%, and this one here, if you notice the X, is going to be the same as whatever this number is here. And then this here is going to be 28%, and it's going to be the result of 3 minus this, because this is going to be the opposite of the, it's going to be the opposite of the yellow. So if I make 2, I'm going to miss 1. So it's just going to be the opposite of whatever I have. So every single one of ours is going to look like this, because 72% is how many I make. Okay, I'm going to make 2. So I have a 7, that would be 72% times 72%. Miss 1, 28%. So let's go ahead and do these and see how this comes up. So for the first one, making all 3, and what I would do is put the video on pause and try to kind of fill this chart out and then look at the answers with me. But making all 3 is going to be, as I said, this here, these are the things that are not going to change. These are not going to change on any of them. So 3 shots attempt, I made all 3. And then if you notice here, this and this is going to be the same. And then when you subtract the 3 minus 3, I get 0. So on the calculator, I would be NCR 3 choose 3, 72% to the third, and 28% to the 0. This next one shows losing, and to lose, I'm either make 1 or I make 0. So I'm going to do the make 1 first. So again, these 3 things are not going to change. This one, and this one are not going to change. And of course, I'm going to 3 choose 1, so that means 3 attempts, I made 1 shot. So that means I have a 72% chance of making 1. How many did I make? I made 1. How many did I miss? I missed 2. So continue down here, and I would say, well, 3 choose, remember these 3 things didn't change. 3 choose 0, 72% to the 0, and 28% to the 3, and I have to add both of these results together since there's 2 ways to lose. And finally, making 2 is going to be these. They're the same. 3 choose 2. That means I have 2 that I made, and then I missed 1. So this I'm just going to carry down here. Is going to be 30, which is right from above, 37.3%, 19%, and 43.5%. So let's see what happens when he attempts a free throw. So the first shot, let's go ahead and look and see.
For the season.
And he attempts it, and he makes it. All right, so let's go back. He's got 2 more to go. He's got 2 more to try. So what happened here is now I'm at 74, 75, and I have 2 baskets left. So I want to know what occurs. So this one's going to be 2 baskets, and I have to still, he still has to make both of them in order to win. So he has a 72% chance of making it, so it's 72% times 72%. And there's a 2 baskets, and he has to make both. So 51%, 51.8%. This next one is, how does he lose? And to lose, he has to miss both shots. That's the only way he can lose. And now it's 2 choose 0, 72% to the 0, and 28% to the second. And finally, the overtime, he can still go to overtime if he makes the first one or he makes the second one. So it's 2 shots, choose 1, and that's going to be about 40%. So let's see how Darius Washington does at his second shot. Sometimes it does that when I hit full screen. So let's just kind of try to manually put it here.
You can't describe the pressure here.
Okay, so he missed that second shot. So now we're going to describe. So now he is at his final shot. He has one more shot, and it's still 75-74. So now he has no chance to win because if he makes it, it's just going to put him at a tie. He has a 28% chance of losing because if he misses, he loses. And he has a 72% chance of tying because if he makes it, he ties. So let's see what happens.
Bert, I will be hard pressed to tell you right now that if you'll see a more pressurized situation this year in this tournament as we're watching right here. Tournament's on the line.
And unfortunately, Darius Washington did not make it. And so Memphis did lose, indeed, the game. So the question was it smart to foul? Now, even though you may say, oh, yes, it was smart to foul because they won. But I'm going to argue with you. I'm going to say, no, it wasn't smart to foul because Darius Washington had a 40% chance to make that original shot that he got fouled on. And that's less than the percentage chance that we saw here to win, plus the percentage chance of overtime. And what I did is I said, okay, let's pretend that he had a 50-50 chance to win overtime. So even half of 43.5% to win, plus the 37.3% chance that it is to win outright is way more than the 40% to win in the first place. So I actually slightly said this is not 21.5, this is 21.75, which actually makes it even a little bit higher, a little bit. So you can see that this is definitely a lot higher. This is like 59.05. 59.05% is definitely much higher than 40%. So no, it was not smart to foul. Guys, I'm talking statistically speaking from the books, this, that, and the other. We're not talking about, oh, it's high pressure situation, it's higher, because you heard the guy say this is probably the most highest pressure situation this guy has ever faced all season, maybe even in his life. So could you measure that statistically? No, if this was the first time he was in a situation like this. However, the 72% and the 40%, those probabilities were not just from one game. They're from every single situation he has ever faced. But you could argue, you could say, well, Ms. Brown, this situation is the first time he's ever faced it, so it's going to encounter way more probabilities, and he's going to miss those shots probably more often than not on the free throw because of the pressure situation. And if you argued that, and you argued that he wasn't going to be a 72% free throw shooter in this situation, then yes, you could argue that yes, it was smart to foul. But given our data and our points that we've been doing, I would say no. Okay, so today, this is what I want you to see, is this is called a binomial random variable. And the reason this is binomial is because it has satisfied the acronym SPIT. Yes, I know SPIT sounds very, very formal and okay, I'm just joking. But this silly little acronym will help you remember that S stands for success failure. Did Darius Washington in this situation have a success failure opportunity? Yes, make or miss. Was the probability the same for each free throw? Yes, 72%. Was each shot independent from the next? Did one affect the other? No, they didn't. They were all independent. And did he have a set number of trials? Yes, it didn't. They didn't stop him if he made it. They didn't stop him if he missed it. He had 3 shots, make or miss. The reason this is important is because if it's a binomial conditions, then we are allowed to use this binomial formula that we just used. So that is good news. The binomial formula, as you can see, is N is my trials, X is my successes, P is the probability of success, and 1 minus P is the probability of failure. And this, of course, and I could actually add N minus X because that's the number, is obviously the number of failures. So that's going to be all of the things that we have in this formula. All right, go ahead and do the whack-a-mole and let's go over the answers. Is this a binomial random variable? Again, you can put my video on pause and then come back to it. And yes, it is, because success failure, whacked or not whacked. It says it's an 80% probability, and it's for every single time. It didn't change. And each whack does not affect the next whack. And there are 20 opportunities to whack-a-mole. So yes, it is binomial. Finding the probability where exactly 17 moles in one round. So n is equal to 20 because I have 20 moles to try. It's asking me, it says, hey, I got 17 of them, 17 successes with an 80% success rate. How likely is that to occur? And I'm going to put this into my calculator of 20 to 17, 0.8 to the 17, and 0.2 to the 3. And you can see in my calculator NCR 20, 17, 0.8 to the 17, and 0.2 to the 3. It gets me 20.5%. Thank you very much for listening, and I'll see you next time.